For years, the artificial intelligence industry focused its public messaging on digital assistants and chatbots. Today, the rhetoric coming from Silicon Valley has shifted toward a single, massive objective: achieving superintelligence. The stakes here are specific. While artificial general intelligence, or AGI, describes a system that matches human capability across economically valuable tasks, superintelligence describes a system that exceeds human cognitive limits entirely. Major tech executives like Mark Zuckerberg have publicly rebranded their company missions to focus on this concept, organizing their operations around a post-human level of reasoning. Building that intelligence requires a massive physical footprint. This projection for the proposed Hyperion data center in Manhattan illustrates a $1 trillion infrastructure boom demanding vast amounts of land and power. Superintelligence has moved out of the realm of science fiction thought experiments. It is now the heavily capitalized, stated objective of the most powerful corporations on Earth. This ambition is fueled by a technical transition in model architecture. The industry is moving away from large language models that memorize and predict text toward large reasoning models that can evaluate and solve logic problems. To measure this fluid intelligence, researchers use the ARC-AGI benchmark. It is specifically designed to test whether a system can solve novel problems it was never explicitly trained on. This 4-panel graphic illustrates how the test works. The system is given visual examples, input and output grids made of colored squares, and it has to identify the underlying spatial pattern. To solve for that white question mark in the final panel, the AI cannot rely on specialized language skills. It has to make a pure inferential leap, much like a child learning basic topology. This chart maps frontier AI performance on these benchmarks. After years of scores flatlining near zero, the introduction of models using chain-of-thought reasoning caused the sudden upward explosion in capability seen in the blue and orange data points. Since humans score near 100% on these logic tasks, these results prove that AI has effectively matched human fluid intelligence in a laboratory setting, crossing a threshold of independent reasoning that was impossible only a few years ago. This scaling of cognitive capability points toward a macroeconomic theory some call the Boomsday, a period of extreme economic expansion driven by AI automation. This chart projects the direct economic impact of that automation. If an AI system can double the output across 50% of remote tasks, models indicate a widespread productivity boost that could increase global gross domestic product by 7 to 10%. As the cost of standardized digital production drops, human employment shifts. Traits that cannot be automated, judgment, trust, and personal care, become scarce, and their market value rises. Looking at this data, the transition in the labor market is already happening. Between 2024 and 2025, job postings requiring generative AI skills jumped by 111% as companies rush to integrate these systems. Advanced AI is moving beyond experimental use towards systematic integration across the global economy. Economic expansion is just the first phase. These reasoning models are now shifting from passive tools into autonomous collaborators in scientific discovery. This flowchart diagrams the structure of a new kind of AI lab. Different AI agents take on distinct roles, like a prompt sampler generating ideas, an LLM ensemble acting as researchers, and an evaluator checking the math, all looping together to test hypotheses autonomously. Looking at the left graph for matrix multiplication, the green line represents an AI system successfully discovering a computational algorithm that outperforms human-designed baselines established decades ago. Biological and mathematical problems that used to require years of manual human trial and error can now process in days. By automating the scientific method itself at this speed, superintelligence offers a realistic mechanism to solve our most difficult physical and biological challenges. But building a heavily relied upon infrastructure out of an intelligence we do not yet fully comprehend carries systemic risk. Safely integrating these models into society requires adherence to responsible AI dimensions, including rigorous data governance, strict bias mitigation, and security protocols to prevent misuse. In reality, deployment is driven by a global arms race for compute. Geopolitical rivals are fiercely competing for dominance, prioritizing speed over cautious testing. This pressure is forcing corporations to integrate superintelligence into critical systems faster than researchers can actually solve the alignment problem. The tech industry's proposed defense mechanism against this vulnerability is a design philosophy called humanist superintelligence. The concept suggests engineering state-of-the-art AI from the ground up to explicitly prioritize human well-being and serve human organizations, rather than operating independently of them. This diagram plots the core tension of our era. AI reasoning capabilities are scaling exponentially, while our theoretical frameworks for global ethics and safety remain linear. We are constructing the cognitive engine for our complex problems. Whether it benefits society depends entirely on human wisdom scaling fast enough to control it.